Hello, welcome to another session on mensuration. We have been taking up questions on surface area of surface area and volume of right circular cylinder. In this last video on this particular chapter, we will be taking up few questions which will include surface area as well as volume of right circular cylinder. The first question, right down here, is a well is dug or a well with 10 meter inside 10 meter inside diameter. I'm not writing the diameter in the hole, let it be as DIA. That is dug. And how depth is it? It's 14 meter deep. Now earth is taken out of it and it is sprayed all around to a width of 5 meters. I'll just draw the figure so that we understand how it looks like. To form an embankment, I can't draw the height of it though. Embankment, we have to find the height of that embankment. Now I told you that I can't draw that because it would be a three-dimensional one, but it would mostly be, this is the well and you draw the embankment which has a height, this one, right? And it says this is the width of it. And this diameter is 10. It has been formed. This is 10. Now if that width is 5 meter more, that means the radius of the outer circle with the embankment will then be 15 meters, right? That means the volume of the earth which has been dug from this white well has been put here. So the volume of this earth is equal to the volume of this portion, right? Now we find the volume of the earth dug here and write volume of the earth dug from that well will be pi r square h. That will be in a form of a cylinder if you imagine the well. So it is, I'm directly substituting it to the formula. That is pi r is given to us as r is given to as, oh, I made a mistake here. This was the diameter, it says. So the radius will be 5. If this radius is 5, then this will be 10. Sorry, I missed that. This is 5 meter and this will then be 10 meters. So here the radius is 5, r square, h is 14 meter, depth of that well was 14 meter which was dug. So this is 22 into 5 into 10. 22 is 5, it's 110. So it is 1100 meter cube. Now this should be equal to the volume or the area, the earth is taken out to spread all around, oh, I made a mistake, all around a width of 5 meter of an embankment, okay? And so what is the area of that embankment? It will be pi r square minus pi r square, but that's shaded regions. It will be pi capital R square minus small r square. So the capital R I have put as 10. So I will put this as 22 by 7. The capital R square is 10, that is 100, and this is 25, so that is 75. It's 22 by 7 into 75. This is not getting cancelled, so let it be because the height of the embankment will be volume of this. I had told you that is again pi r square h. So this is pi r square h is, suppose, let it be as h. This volume is equal to the volume which we had calculated at 1100. So h will be 1100 multiplied by 7 multiplied by 22 into 75. I think if we solve this, I'm getting this as 4.66 meter. That is the height of the embankment which has been drawn out of the mud dug from this well. So the volume of this area equal to the volume of this area. Let's move on to another question. I'll write the next one. I write it here. Okay. 2.2 cubic decimeter of brass, I read as of brass, is to be drawn, that means is to be drawn into a cylindrical wire that is of 0.50 centimeter in diameter. Find the length of the wire. We have to find the length of the wire. Let's see. Let's assume that the length of the wire we take as supposedly L. I'm taking this length of the wire as L centimeters. Suppose we have to convert that decimeters as well. Okay. Now a wire means what? It's a cylinder only, so which has a diameter 0.50. That is divided by 2 will be 0.5 by 2 will be 0.25. The length which we have taken as L means the height of that wire. Now what is the volume of the wire that has been, volume of the wire, that is pi, and right here volume of wire, that is pi r square into h, that we have assumed to be L. But the volume given which has been used from the brass is 2.2 cubic decimeter. 1 decimeter is 10 centimeter. So 1 cubic decimeter will be 1000 cubic centimeter, right? So the volume of the brass that has been used is 2.2 into 1000 cubic centimeters. So it is 2200 cubic centimeter. This volume has been used to convert that into a wire. So the volume of the wire is equal to 2200. So L can be calculated as 2200. That means this many length of the wire is drawn. But this into 7, this divided by 22 into 0.2 into another 0.2. So I just need to remove these decimals. To do so, I will be multiplying 100 in the numerator. So it will be 22 into 2 into 2. This is giving me 100. So this is 50. This is 25. Am I right in doing this? It is, oh, I think a mistake here. No, it is 0.2 into 0.2. It is pi r square h. Did I do that rightly? Yeah. Oh, I made a mistake here by calculating 0.5 by 2 gives you 0.25. This is 0.25. This is also 0.25. I'll just erase this part so that I do it again, because I got that wrong. Hey, I just missed that part, which was 0.25 here multiplied to 0.25 again. I need to remove the the decimals, thereby multiplying 100 and another 100 in the numerator, thereby getting 22 into 25 into 25. This is 4. This is also a 4. This is 100. So 4, 4, 16, 7, 1, 1, 2, 0, 0. This is in centimeters, so we can express it in meter as 112 meter will be the length of the wire, which is drawn from 2.2 cubic decimeter of the brass. Let's move on with another question here. I'll write down the next one. It writes that the difference between outside, oh sorry, I missed a letter there, outside and the inside surfaces of a cylindrical metallic pipe 14 centimeter long is 44 square centimeters. Now if the pipe is made of 99 cubic centimeter of metal, we have to find the inner and the outer radii of the pipe. Radii of the pipe, right? Okay, as because we are dealing with outside and inside radius, I will mark the outside, that is the external radius, as capital R. We write the external or the outer outer radius as R centimeter, and the internal radius as small r centimeters, right? It also informs that which has 14 centimeter long. So the length of the pipe is 14 centimeter. We can write it as H as 14 centimeter. Now the difference between the outside surface area, that is 2 pi RH, minus the inner surface area, that is 2 pi RH, is given as 44. So it will be 2 pi R minus RH is equal to 44. So it is 2 into 22 by 7. The capital R is R, small r will be R, height is given as 14, this is equal to 44. So R minus R will be 44 into 7 by 2 into 22 into 14. This is 2, this gets cancelled, so I'm getting 1 upon 2. This is first equation. We can see that capital R minus small r is 1 by 2. That is our first equation. I'll erase this which I had numbered. Let it be in clarity. This is our first equation. It says if the pipe is made of 99 cubic centimeter of metal, that means this volume, which is this is the volume of the metal. That means it is this 99 cubic centimeter is the volume of outer volume minus the inner volume is this. I need some more space. I'll need to move the screen here. So it is external volume minus, I'll write external volume minus the internal volume, that is given as 99 cubic centimeters. We don't need any conversions, they are all in centimeters. So this is given as pi capital R square h minus pi small r square h is equal to 99. Again, I can take a pi common, thereby r square minus small r square h was given as 14. This is equal to 99. So I'm getting 22 by 7 into r square, minus r square multiplied to 14 as 99. And if I continue with it, I will be getting capital R square minus small r square as 99 multiplied to 7 by 22 into 14. This is 2, this is 2, this is 9. So it's going to be 9 upon, am I getting this is 9 upon 4? I made a mistake here somewhere. I need to write it neatly. I think I made some mistake somewhere. It is 99 multiplied to 7 over 22 into 14. I know I did it rightly. This is 2, this is 11 2, this is 11 9. So I got it as 9 upon 4. Now if you see, r square minus r square is 9 upon 4. If we have, this is another equation, I can write this as another equation, but I can use this one and I extend. Hope you remember this one, just need to, I'll need this later on. Now r square minus r square, if you expand it, makes you r plus r. This is application of the third identity, is r minus r is equal to 9 upon 4. Now if you see, we had got r minus r as 1 by 2, that I'll substitute here. So I'm getting r plus r multiplied to 1 by 2 is equal to 9 by 4. So r plus r is equal to 9 upon 2. Now this is, suppose, our third equation. I have r minus r as 1 by 2. I have r plus r as 9 by 2. I'll use this to find r and small r and big R. One was r plus r is 9 by 2. And our first equation was r minus r was 1 upon 2. If we use this, I'm getting so I'm getting a cancel here. So I'm getting 2r is equal to 9 by 2 minus 1 by 2. That I think I'm getting as 8 by 2. Do I need to solve this part? Yes, I'm getting 9 by 2 minus this as 8 by 2. So R I'm getting as 8 by 4. So small r is 2. So we got our small r as 2. We also have to find the outer radius, that is the capital R. We know from the first equation that r minus this was 1 by 2, and we can find the capital R as 1 by 2 plus r, and that I got to be 2. So it is, it is 4, 1 by 2 plus 2, that is 5 by 2, that is 2.5. So this is your answer for the capital R. So I hope you have followed this question. We will move on to another topic in the next few videos. Thank you.